Where did you?
Yeah, but I didn't do it.
That's fine. That is compatible with what I said.
Did you never know how you said that? Oh, now I'm in. Okay, all right. Early whenever. Hi, if you're here for something other than Secdispatch, go find where you would like to be. Otherwise, welcome. Kathleen Moriarty.
Richard Barnes. And together, we are Secdispatch. Actually, no, all of us together are Secdispatch.
We will dispatch to you.
All right.
Note the note well. All right, so logistics. I guess the first presentation will fall out of the normal format, and Michael Richardson is going to talk for 4 minutes and present for 4, and the rest of them have a 15-minute time slot.
I think we're going to do 15 minutes presentation, 15 minutes discussion.
Yes.
Yep. And then we'll wrap up. Anyone have last-minute modifications or proposals for agenda items? Last call before we launch into it. All right, seeing no agenda bashes, Michael Richardson, please join us on the stage. There's a pink X up here with your name on it. We got the bigger one just for you.
Hi, Mike Richardson. I'm in topic of clarification. I
don't think the mic is
the microphone is not on. Hello? Okay. Hi, I'm Michael Richardson, and I've been working on a document called Bootstrapping Key Infrastructure, and it's an extension of RFC 7030, which was produced by the PKIX working group. And in the process of doing interop testing, we discovered some oopses. Next slide. So RFC 7030 runs over HTTPS and lets you do certificate enrollment using CMC methods. And throughout the document, it believes it's running over SMIME rather than HTTP. As a result, it asks you to put content transfer encoding headers in with, let's say, base 64, and then asks you to base 64 stuff that could be binary. And so that was a bit confusing. So it turns out that there are no actual real implementations out there of it that actually put the content transfer encoding header in, because it's actually deprecated by all the HTTP documents. So implementers are left wondering, does that mean that I should put binary in the in what's there, or base 64 encode it? And the answer is the document said to base 64 encode it, so they did. With the result that people were like, oh, okay, it's base 64 encoded. Well, is Brewski base 64 encoded, even though it doesn't say it? And therefore, we got into confusion things. And it also makes it a little more confusing because people like to run things with curl, which is really hard to dump binary objects into it, but really easy to dump base 64 things in, and people don't always realize whether they're providing a convenient encoding to curl or whether they're actually, that's what they're transmitting. Anyway, so this is a document that basically attempts to clarify these four points. Two of them, errata, were raised by Sean Turner. Next slide, actually. That's the content part. Two of them were raised by Sean Turner on this topic. There is an ASN1 complaint about the document that it does it wrong, and I actually am not, I have no idea if it's right or wrong, and I need help on that. And then finally, there's a typo that apparently, an extra space that apparently one implementation believed was mandatory and insisted was there. And then they realized it was just, it was a typographic issue in the document when they tried to interoperate. So those are four things. It's just a simple clarification document on it. I don't think it's worth revising the BIS. Next document, next slide, please. I don't believe it's worth revising the document or doing a BIS at this point. You may have seen my 0001 documents, which went on the assumption that content transfer encoding was actually being sent, and we actually could upgrade everything to binary if only we could change what was there. And after a fair number of feedback, we realized this was impossible. It's got to stay the way it is, and we just need to document it as this is broken in the following way. Deal. That's it. Any questions?
You have 4 minutes for questions if anyone would like to ask clarifications about the clarification stuff.
Or tell this group where the document should be processed.
So just to recall the dispatch options, we could form a new working group from this document.
Yay.
We could hold a BOF. We could dispatch it to an existing working group,
right.
AD sponsor, or we could tell you to go away.
You tell me, yeah, gone. Yeah, my suggestion is either to send the document to LAMPS, which vaguely has inherited PKIX stuff and probably has the ASN1 clue to fix the other part, or AD sponsor it.
Yeah. And I believe Alexei has volunteered to
do
sponsor.
That. Yeah.
If folks think that's appropriate. Martin.
Martin Thompson. I have a slight preference for going to an existing working group if you can find one that is willing to take on the work. Some of these working groups don't really have the charters for it, which makes it a little tricky. So I don't really mind either way.
I also prefer that because I think it'll get the better early review on the ASN1 thing that it needs rather than happening and discusses.
So the thing that occurs is perhaps you could monkey patch this in some way using content encoding to avoid the base 64 issue. But I don't know if we have a base 64 content encoding. So that would be new work. And so it might, content transfer encoding is not a thing in HTTP. So let's not pretend that happened. But we might be able to do something that will, for those that implement this correctly up to the new standard, won't result in any confusion.
So of the 4 or 5 actions that are defined, all but one are posts, and so the client has to somehow guess, having never spoken to the server before, whether it accepts this new format or not, and that turns out to be non-trivial unless we go ALPN or something, I don't know what, but I think it's do not fix, just cope.
Just document it and move on. Yeah.
All right. So hi, I'm Sean Turner. The joke comment is we should just rename lamps, PKICs, live forever. But I think you should probably send it there since it's already it's the PKICs thing. You should send it to lamps. Lamps. And you should rename PKICs or lamps to PKICs Prime or something great like that. May it long live forever. I think we should definitely fix these things. I don't know, I was considering whether we could use the HTTP accept header to try to tell the server what you support. That was something that Mark Nottingham suggested at one point, that maybe there's some way we could figure out how to do that. I don't know if that'll work, but it's something to propose. And I guess in the errata that I submitted, there were some suggestions for workarounds about should be expect to do this, so that. So maybe those weasel wording will work and maybe it won't.
And that actually works great for the response, and I actually implemented it, but it doesn't work for the post.
Yeah, fair enough.
And then I went, oh.
Yeah. So all right, I will step out of the way because I'm no expert in that. So.
Hi, Roman Danilio. We can say lamps, and that's okay. I'd love to hear if folks are directing kind of toward lamps. I would just remind we probably need to have a charter conversation relative to that.
Exactly. So,
Rich Sauls, the other reason to send it to lamps is that's where Jim Schad and Russ Housley hang out, and they are the ASN1 experts.
So, thank you for making my point for me.
Martin Thompson, back on the post issue. There is an RFC that talks about content encoding and client requests, and I think that we're almost in that area. And so there's a bunch of text about how to deal with that in that RFC. I can send a pointer to.
Which document is this?
RFC, blah, blah, blah. I can't remember it off the top of my head, but I'll find it for you and send it on.
The 7230 series or something else?
7230. So I forget the exact number.
But one of those, you mean?
Yeah. Something in the HTTP area. Yes.
Okay. About content negotiation for post is what you're saying.
For request bodies. So, yes. Okay. Exactly what you're talking about.
Okay. Just so the speakers know, there's echoes off of this wall, so it's weird. I can hear him both directly and off the wall and off the speaker, so it's just really weird. Yeah.
Martin, speak up. So, Michael, it sounds like your preference is to go to lamps. Sounds like there's some comments from the floor to dispatch this to lamps. Russ Housley's standing up. Is he coming to the mic as lamps chair? Okay. ADs, I'm looking to you. Does that sound like a plausible outcome? Okay, great. Okay. So we'll consider this dispatched to lamps then. Thank you. Next up is Dave Carroll for some controller Ike.
Okay. Do you have slides? They are. Oh, they're up. I can't see them down.
And there should be a clicker there if you want to try and drive them yourself.
Okay. Does this not work? That's too bad. All right. So I'm here to talk about controller Ike. This is something we started doing in SD-WAN work, and it's been growing in the routing group. A lot of interest in it. It is basically a key management protocol. What is it? Ike is basically a key management protocol that'll drop in place of standard IKE, except it works through a controller. You know, the concept is there is no peer-to-peer direct messaging. What else? At a high level, it's pretty simple. So what we're doing is a Diffie-Hellman exchange, just like, you know, the idea is to try to make it similar to Diffie-Hellman you would do in IKE, but we're doing it through a controller, and we're trying to keep the scale of the messaging down. So the problem we came up with that we had to address was that we had, when we were doing large-scale networks, we were doing 10,000 plus nodes in a full mesh, and there was too much IKE going on. The amount of traffic over the network was too high. The complexity just was not manageable. It was n squared. And so by coming up with a controller-based model, we've reduced the messaging to order n. Basically, each peer creates a Diffie-Hellman public value, sends it to the controller. Controller collects these all and sends them all down. The concept is very simple. Where this gets interesting is when you try to synchronize. Obviously, you'll have to do rekeying. And when rekeying happens, you have the problem that keys get distributed to different peers at different times. For redundancy reasons, you'll want to have multiple controllers. The state isn't always the same. And so the draft that we put forward addresses the synchronization and shows how you can handle that with a centralized controller-based key exchange. Yeah, and the key there is no peer-to-peer messaging. What isn't it? We're not pushing this as a replacement to IKE. Obviously, IKE has stood the test of time. It's around. But in certain models, we find this to be a little more ideal. It is also not a two-way attribute negotiation protocol. You can end up with two peers in IKE that may offer different things than the other wants. In this, there's much more of a limit. You've got to, but in this model, we're coming from a centralized controller, and so we're not as worried about needing to negotiate completely disparate options. There is a small ability to negotiate a hierarchy for, you may have a couple of algorithms and you can negotiate down. I won't go into the details, but it's in there. And the other key to this is we're not providing the secure communication to the controller. So this is a protocol that is embedded in something else. In the Viptela SD-WAN products, we have our own protocol that is secure. In the routing working groups, we are working with BGP in secure BGP messages, and that's all taken care of as part of the communication to the route reflector. So why do we want to do this? So the key for us is optimization. We reduced the complexity, we've reduced the messaging from n squared to n. But there's other attributes to this that have been really helpful for us in SD-WANs. So one of the keys that we found is we have customers that want to do control over a managed secure network. They may have an MPLS link that's provisioned. They have whatever they have. But the data doesn't necessarily go over that same network. And this allows us to do control over one, messaging over another. The other side of it is we've worked with at least one customer that had some very odd-shaped networks. They had links that were not bidirectional. And so you have a case where two peers cannot talk to each other bidirectionally, but they can each talk to the controller. And so we can provide a way to do key management and still have a one-way IPsec tunnel. So where is this being used? I'll throw out a few drafts here. These are things that are being pushed forward in some other working groups. I know IDR, I think it's tomorrow, is going to be talking a lot about security architecture and directions that this is headed. And this is hopefully intended to be one part of that architecture. Wednesday. Got it. Not tomorrow. And this has been discussed. Drafts with this have been presented in BESS. It's been discussed in IDR. Even the I2NSF work has looked into this, and this could fit in very well with the I2NSF infrastructure, though not as the messaging portion, just the configuration, much like Ike. Who? We'll skip by that. So when is stuff happening? There are currently 2 implementations of this draft that are known to be there. To be fair and honest, they are very incestuously related. So maybe it's not quite 2, but the stuff is working. It is going. It's also currently under consideration in a number of working groups that are looking to try to integrate a controller-based key management for SD-WANs, for overlay networking. And then this is kind of my last slide. I've tried to do this rather quickly. And the next question is, when can we do something else, something to move forward?
Eric Wishkola. Higher on the couch. Thank you. So I guess first I have sort of a clarifying question. When you say it's not n squared and it's n, what units are you counting in?
Messages.
Okay, because it clearly is n squared data.
The Diffie-Hellman calculations are still n squared, correct?
It's n squared data transmission as well, right? Because you have to send, everybody has to send n up to the controller, which sends n out to everybody fan out, right? So if those are unidirectional connections, it's still n squared, right?
It's 2n. Everybody sends a message up to the controller sends a message down to everybody else.
But that message can, that's the difference between data and messages, right? Anyway, this is
2n, it's order n.
Again, if you're counting messages versus bytes, things are very, very different. You're paying, I mean, so this is like, by the way, skip. In case people don't remember history, this is basically the same protocol that Sun originally proposed for IPsec, and we ended up selecting Ike. As with skip, you're paying a lot for this, which is you're not getting PFS, and you have sort of odd protocol design without confirmation. I guess, as I said in my email, an alternative design is to do effectively, is to basically do key establishment only when you need it. And then basically the overhead you're paying is whatever messages you're sending in addition to the actual communication you're sending. Because I assume you do intend to send packets, right?
You do intend to send data packets.
Right, yes. Exactly.
But not necessarily bidirectionally.
Understood, but you don't need, there are plenty of designs which don't require bidirectional communication and still get you better guarantees than this does.
Okay.
So,
I'm not trying to push forward that this draft is the be-all, end-all protocol for a controller-based model, but I would like to start the discussion on a controller-based model not using the peer-to-peer.
Well, I guess I would encourage you to sharpen, I'd encourage you to state the requirements rather than stating the design you're looking for, because it seems to me that the requirements that one backs out of this don't necessarily get you to the conclusion you just got to.
Okay, I'm not sure what requirements are.
Well, you're saying you don't want to do peer-to-peer, but why?
Say again?
You said you don't want to do peer-to-peer, but what resource are you conserving?
I don't always have peer-to-peer bidirectional communication. I'm conserving messages. Messages are costly.
Just to like propose an alternative hypothetical here. Imagining everyone has bidirectional connectivity to a controller. One design you could adopt is to do normal IKE directly between normal IKE from one peer to another, but tunneled via those controller connections. Right? So that you do normal IKE full mesh, but over the controller connection because you have bidirectional connectivity that way. So I guess I think kind of what Ecker's asking is like, how does this design differ from that one? given that both of those use the controller to route messages between the various endpoints.
Well, at that point, again, now you're doing n-squared messaging, and you're doing it all through the controller, which is going to become quite a bottleneck. This is where we came up with as a more optimal
I was next,
approach.
right?
So my follow-up that might clarify what Richardson and Mike Richardson is, do you have a goal to be able to work between split brain controllers where there's multiple controllers and they're no longer they're partitioned within parts of the network and still have things happen? In other words, do you have an idea that you might also be doing IKE between controllers to build meshes between networks that were partitioned as far, on their control links?
I have implementations that do that today. We work with multiple controllers where each peer may only talk to one of the controllers.
Does it look like IKE v2 between the two controllers?
It does not do IKE v2 between them. It does something very, very similar to this.
So, please, Alex Ajasi. So one of the use cases for the controller is BGP route reflector. And there are redundancy built into it, and we do this point-to-multipoint signaling. It has been there for past 15, 20 years, been proven. And the idea, and we've had many services, VPN services, based on this controller. Last but not least, eVPN. And there is requirement to be able to add security features to eVPN and leverage that controller. And this is one of the drafts that we are introducing in the BES and IDR working group, and it is getting good traction. And the idea is, I have the controller, I'm doing the signaling for my VPN and many other things. I like to be able to use the same controller to leverage it for point-to-point tunnel setup. So the signaling connection is point-to-multipoint, the signaling, but the tunnel, IPsec tunnel that gets set up as a result of that signaling is point-to-point. And the work in terms of how that signaling is done, as I said, we've introduced a draft in BES, and we're getting pretty good interest on it.
Thanks, Linda.
Linda Dunbar from FutureWay. I strongly support this proposal. I think the IPsec has been in the industry for many decades, right? But primarily it's peer-to-peer. However, in today's environment, for example, for enterprise going to the cloud or enterprise going to multiple clouds, you have an edge device. It's no longer just one connection to my peer. We're talking about multiple connections. I have an edge device. I may have 5, 10 tenants connected to my edge device. Each tenant need to talk to their peers, right? So from one edge, so supposedly if I have just simply 10 nodes, that's not talking about 100 nodes network, 10 node network. If I have to connect with all my peers, so that means I have to have 9 connections to all my peers. Now if I have 5 tenants attached, each of them need IPsec. So that's 5 times 9. So for one node today, I have to support 45 peer-to-peer key management. That's a lot of work. And in addition to that, for SD-WAN, for the device connecting to the multiple cloud, there's always a controller. Doesn't matter. It's not just for this particular purpose, for other purposes. Need a controller. So as a device today, you already have a secure connection with the controller. Through that secure connection, you can distribute all those key informations. Not directly key information per se, but rekey mechanism, all those kind of requests to rekey. So that make the whole network scalable. Otherwise, just unimaginable. One node probably have to handle hundreds of keys, and that's just not manageable by a small virtual device, especially in the cloud. So I support this approach. Maybe this exact mechanism doesn't have to be the one, but this controller-based IKE has to be something to be discussed by IETF.
So we have about a minute left per person before we need to start wrapping this up, so please be brief.
Okay, Yoav Nir, co-chair of I2NSF. This was presented in I2NSF, and I2NSF has this document about using a controller to initiate IPsec, and we have two modes or cases, one with IKE and one without IKE, the IKE-less as it's called. And we saw this as kind of a middle ground. And what I'm missing is, what does this give you that the IKE-less case does not give you?
So in the I2NSF flow protection, the IKE-less case is simply having keys produced at the controller and pushed down to the ends. So the controller now owns or knows every key used in the network. There's certain obvious limitations to that sort of model. In the past, I've spoken in I2NSF about trying to integrate this into that flow. And since then, this has somewhat evolved with the routing groups. And the notion would be that I2NSF would be used to configure the static configuration for either an IKE or a controller IKE. But then the actual dynamic messaging would happen through a route reflector, not through the I2NSF Yang model. I think that's a much cleaner design with what I2NSF has put forward. But that's also open for
I don't see
discussion.
why we need both that and both this and that. There's too many ways to get to the same thing.
So does this need to be revisited in I2NSF after developments?
Well, the I2NSF document is pretty much done, so probably not with this document. If somebody wants to extend it later, I2NSF may be the home. I don't really think so.
So the architecture that's currently being put forward in BESS, as far as these dynamic routing models, has a configuration server that configures nodes as they come online. They need to do some sort of ZTP or something else to connect to the network, and they get a configuration pushed. But then there's the dynamic routing where they send the overlay routing to the RR, and that would be a more ideal place to send key management updates.
Yeah, so I think since we're dispatch here, we're not like building a protocol. Sounds to me like there's some confusion about the actual requirements here. Maybe not by you, but by other people, at least by me. And since designing AIKs is kind of like difficult and getting them right is not easy, I think it'd be really useful to get like a somewhat clearer statement about how this problem domain is sufficiently different from other problem domains that we can't leverage something we already have. And I think the exchange you and I had earlier suggests at least I don't understand this properly, which would be entirely my fault. So I think in terms of dispatching this, what would be really helpful would be to basically have a clear problem statement that actually make clear like what this use case, how it's different, and potentially in ways that are more constrained and perhaps bandwidth in ways that are less constrained in terms of having the controller available. And then we can see what protocol actually makes sense in those circumstances.
We had presentation of this in IPsec ME some time ago, I don't remember, and the conclusion was that this doesn't have anything to do with IPsec, so we don't want to do it in IPsec working group. So if somebody is going to propose that, that's a solution to that. We are not going to take it in IPsec ME because it doesn't have anything to do with IPsec. The other problem I have is that it assumes, like Eric was saying, you don't have really requirements. It assumes that your whole network is static, because if you start building this network one by one, you have one node, then you add one node, then you add node, then you have n-skewered again. Because every time you add a node, you need to send that one node sends a packet to controller sends a packet to everybody to tell us, oh, that has a new, public key here. And then somebody adds, it sends again. So every time you add a node, you send n packets, and you add n nodes, it's n times n. So n to square. So, but if you have everything ready, you have 10,000 nodes there, you can send the 10,000, public keys at the same time, and when the network starts. The other problem I have there is that you have to always, the benefits for IKE is that you create the keys only when you need it. If you have 10,000 nodes there, you don't have to create the node and essays when you boot up. You create only those essays that you need when you talk to somebody. And in most of the networks or environments, you don't need to talk to everybody in the network every time, all the time. you talk to, handful of people who are, next to you or this kind of thing. So you have very, strict requirements that are not really, or use cases very specific, this kind of thing. You have static network where everybody happens to talk to everybody all the time, and you create the whole network in the beginning.
So let me address both of those. Actually, this works really well in dynamic networks. When you start bringing nodes online, the node simply has to contact one source, the route reflector, as it were, in the routing model, and update it with its Diffie-Hellman information as well as the overlay routes that it knows. All right, and the overlay router is regularly sending these updates to all the other routers. So it gets to them anyway. He's not adding to any load. We had, if you have 99 nodes and you add one more, it's simply the next update from that controller is going to have 100 entries instead of 99. It tends to work really.
But that's still sending 100 messages to 100 nodes, which is, yes, because you send periodic messages, which IKE doesn't. You're actually generating much more traffic because you send every now and then you have 100 messages to everybody telling that
you were sending, the controller was sending 99 messages out anyway. Yes. With the latest status update. Here's the latest update on the routes. Here's the latest update on keying information.
If you count how many status messages you send over the lifetime of the network, I think that actually is bigger than what you do when you actually create the IKSS.
I think thanks. Okay. Thanks. Phil?
Phil Hambaker. It strikes me that this isn't so much a key exchange as a message flow. And I'm very interested in this, and here's why. Quantum resistance, at the moment we've got no solution for it. There are proposals, but the only thing that we could deploy today would be Kerberos. And this actually, if you look at the protocol level, it's looking pretty close to Kerberos. And so I think it's interesting to look at as a fail-safe in the quantum resistance world. And so I'm interested in that point of view. As far as where it gets dispatched to, I'm pretty sure that this is not an AD-sponsored draft.
I would agree.
So I think that it's a working group. It sounds like it's not IPsec, so the question is whether it's a working group or not anything at all.
So just to add real quick, we've done a bunch of thinking about quantum resistance with this, and it needs more work, but yes.
Let me cut the lines here, and please be brief.
This is Hannes. Since you're doing a performance optimization here, I was wondering whether you posted something about the details of that performance improvements, because I got a little bit confused on the discussions on the scalability aspects, which I didn't quite see in the number of nodes that were mentioned. I would like to see some of those details clarified. Did you publish that already? Again?
So
you'd like to see what?
He's doing a performance optimization. Maybe he has already written up something about the details on the performance gains that he expects to see, but I'm just not aware of those.
Thank you. Just from that mic is super hard to hear up here.
Okay.
For everyone.
Alisa Jesse, I think there was a misunderstanding by the other gentleman who was here and talking about if you add a node, then you're going to end up sending tons of messages. That's not the case. When you add a node, that node talks to the route reflector, which is the controller, and gets the information from the controller. So you're not sending any other messages. And the saving is on the ingress nodes, or the node that you keep adding to the network. Those can be a very low power, low-end nodes that don't have the CPU capacity of sending ON messages. And in this case, we are just the node send a single message to the controller, and whoever comes up taps to the controller and gets that message. And they get their public keys and calculate their share key.
Dan?
Yeah, thanks, Dan Harkins. I noticed that there's been some people coming to the mic and talking to you about better ways to do this. Eric had a suggestion, Tara had a suggestion, the last guy, I'm sorry, I don't know your name. We're talking about, different ways to solve this problem or to do it better or something. So it looks like there's enough interest in this kind of a problem. And so I think when is probably, real soon now and probably right now. But I think where, I don't see why it can't go into IPsec. This is no more of a weirdo key exchange than like the GDOI stuff that we did. So it seems like if process is the reason we wouldn't do this, it seems like a really poor outcome for the IETF. It looks like there's enough interest in doing something like this. It looks like it solves a problem. So, let's put it in IPsec. And if we got to change the charter, then let's change the charter. So what?
Well, I would have to say, I don't want to disagree with the IPsec working group chairs, but to me, this is an IPsec thing.
Yeah,
we're using this solely for the purpose of keying. Hang on just a second. We're using this solely for the purpose of rekeying IPsec. It's providing a function that Ike provides. It's providing a function that the GDOI stuff did.
No, you are using ESP. You are not using IPsec. HIP allows you to create ESP packets, keying material. HIP is as much of Ike that this is. Yes, you can use multiple key management protocols to create IPsec ESP keying material and ESP, packets. But that doesn't make it IPsec. And the people in the IPsec MA group are interested in IPsec, which includes Ike, and they were not interested in this because they see that the only, very small piece of this is the ESP that is common what they are doing now. So as I said, HIP is using ESP. It has exactly the same common, understanding that this one, and I don't want to have a HIP coming here. GDOI is actually using Ike version 2 messaging between the peers, and it's actually using Ike version 2 framing. That's why it's much more closer. And there was lots of people who were saying, "Oh, do we actually want to do that?" The option was to have a separate, working group, and we decided that it still has most of the same people would be interested. That's why it's in the IPsec MA.
This is Linda Dunbar again. Since it's a dispatch group, I think we should first reach consensus. This is some work we should do from IETF perspective. I heard earlier a comment about adding one new node will trigger so many messages. I just want to add one more point that for example, I just use SD1 as an example. All the nodes have to get controller to dictate who he can communicate to, because we're talking about the overlay network. I'm here in Montreal. I have my peer in Dallas, and I don't just talk to Dallas. Maybe I'm not even allowed to talk to him. The controller has to dictate who I talk to. So it makes more sense to have a controller dictated controlled IKEY, so that they can send to the controlled group. So that's just one more requirement I think we should cover.
Okay, thank you.
We're going to have to, obviously, any AD can get up and speak, but we're going to have to try to wrap up.
Ben, would you like to wrap us up here?
Yeah, so there's, I think, still some lack of clarity among many people in the audience part about what the requirements are. We heard some talk in passing about the overlay network and maybe an implication that, wow, this echo is really bad. Anyway, and maybe the implication that with the overlay network, you may not actually need to give every node the key from every other node, which would get into some of the scaling and number of messages questions that were raised. So it's not really clear that the people in the room have the information that they need to make the dispatch question. Maybe we should have more discussion. Maybe we should have a mailing list that we can do that. Or do you want to keep it on Secdispatch?
Yeah, as you guys like. I think we can have some discussion on Secdispatch because it's still discussing how to dispatch it. Or if you'd like a new list where you can have a more focused discussion, more focused group, I'm sure the ADs seem amenable to approving that.
Sorry, I think we're done. And I'd say you've gotten a lot of good feedback. This is a really active discussion. So, some of the points that came up were revising the requirements so that they were clear, and a revision of the draft would be helpful. If the ADs want it on a separate list, that of course is is an option, or we continue to leave it discussed on Secdispatch for a while until it's down to home. But there's clear interest.
I'm comfortable leaving it on Secdispatch unless there's a desire to have a new mailing list.
Okay, so nothing for now except revise and define requirements more clearly, right? And then we figure out next steps.
Okay.
Thank you.
Thank you.
Hello, I'm Phil Baker. I'm here to present on the mathematical mesh. So internet security is broken. It's broken because we keep being told it's broken in the news. And if you look at what we do here, we use very little cryptography that isn't described in Bruce Schneer's Blue Book. We don't use anything from the Red Book. We've improved some of our algorithms, but we're still approaching the problems in the same way. Things like SMIME, OpenPGP, the users find them too much effort. They're not using them, and they're not going to change. So we've got to change our approach. And if you look at the problems out there, most of the breaches are of data at rest, and we focus on transport. We've got to look at the data at rest problem as well, because that's where the breaches are. The approach that I want to apply here is metacryptography. I want to go beyond the PGP canon. And one key cryptography, DES, allows you to solve a lot of problems. ATM systems were made possible by DES. However, two key cryptography allows you to do more because you can separate out the roles. When encryption and decryption are different keys, different people can do it. So if one key cryptography is good and two keys are better, why don't we try 7 keys? Yeah. So it's about moving towards more keys, more separation of roles, more separation of duties. And this allows you to do some really cool stuff like have a cloud service out there with all the encrypted data that can encrypt stuff but doesn't have the ability to decrypt because it doesn't have any, although it's the key manager, it doesn't have any actual keys. So the solution I've come up with for this is more than just an application, it's really a platform. And when you look at what you need to support this and make it usable by end users, you need to do 3 basic things. You need to be able to join together all their devices into one gestalt so that they can read the Word document, read the Excel spreadsheet, read their email on any one of them. People aren't going to use PGP if you can't read your email on every one of your devices you currently do. So you've got to have a way of doing that key portability. You have to have a way of establishing trusted relationship with other users. And you have to have a secure control plane messaging to support all of the above. And the thing is that when you've got all that infrastructure to support this one application, well, you can use it to secure almost everything else, or to make the use of anything else easy. When I showed this to Dave Clark, he said, well, SSH, can you do something about making SSH easy to use? Because the thing about SSH is, okay, it's not that difficult to use. However, if you make a mistake in the wrong time, somebody's got to get on a plane to fix it. And I've done that. So I've designed it in such a way that you can reuse this thing in other stuff. And it's designed with a deployment strategy that even though this cloud computing multi-key cryptography is where I want to end up at, that's not the first application I'm looking to sell it as. There's a bunch of technology out there. I'm going to go through a summary of just a few of them, but there's more technology there, and it can be used. Oh, and it's all MIT licensed. It's all unencumbered as far as I'm aware. It should be good to go. So one of those technologies is PGP fingerprints revisited. Allow us to represent any output, not just an MD5, as a base 32 encrypted screen. And apply this to content digests, to nonces, encryption secrets, Shamir secret sharing, HMAX, allow you to present that data in the same syntax. Now you're asking, why aren't these URIs? Well, they're not URIs themselves, but you can put them in any URI. And here's what you can get from putting it in your URI. So we have here an encryption key, and we've added to it a domain. Okay, so that is a URN with a domain. It can't be resolved by a regular browser. But if you take the fingerprint, the content digest of the encryption key, and you slap the well-known service on top, now we've got a locator. We can pull an encrypted document and then use that encryption secret to decrypt it. Okay, so now we've got a URI that allows you to retrieve and decrypt the information. Let's present that as a QR code. And now you can put something on your business card that links to a PGP fingerprint that's actually actionable, locatable. And so I use this type of technology to connect devices to a personal mesh or contacts to a mesh account. And you could also use it, though, on applications like put a QR code on an invoice or a bill or your tax return, links to electronic copy thereof. And all that data in the cloud, it's all encrypted. So even if the cloud is breached, the data isn't. One of the technologies is the replacement for PKCS7. Now, this wouldn't be essential in itself, but the reason that I needed to fiddle with it was because I wanted to do the multi-key cryptography stuff. And by the time I'm finished, there wasn't much PKCS7 left. And so I get rid of the legacy. And I designed it so that you can stack envelopes together to make a container. So you can now do blockchain-type integrity checks. You can create a Merkle tree as you add your envelopes to the container, take the envelope out, give it to somebody, check the signature on it, and now you've got one signature check, one signature on the container can authenticate any message. So it's a way of doing incremental authentication. You can also do incremental encryption. So one key exchange at the start of the log file can be used to encrypt any subsequent entry. And these are all flexible, they're options, not requirements. So what can we do to create applications out of that? Well, in the mesh, I use these to support my mesh accounts. Mesh accounts belong to the user, not a service. So when you go and you start up the mesh, you create accounts for yourself. And then you decide whether you want Google or Microsoft or whoever to support them. And if you want to change, you can, because they're designed to be low switching costs. We could use the same exact technology for your server logs so that you can get to GDPR compliance, or rather, make it cheaper to get to certain types of GDPR compliance, where you're trying to make sure that you know exactly who is reading your server logs and who is analyzing them. So what I'm trying to do here, this is almost zero trust cryptography, but not quite. I'm trying to distrust each party as much as possible by separation of roles. So if I buy a piece of equipment, I attach it to my mesh, I don't want to trust any key that the manufacturer has put in there during manufacture. But I certainly want to make use of such a key, and in particular, if it's put in there during manufacture in such a way that it can't ever come out. And so I use the same metacryptographic techniques that allow me to split keys to combine them. And this is all technology that Matt Blaze, Torben Pedersen, and others developed in the 1990s and didn't get used because it wasn't part of the PGP canon. And so it's about moving forward beyond that canon to do something else. So as I mentioned, I have a messaging plane here. Now the idea here is not to replace SMTP. Well, not immediately, but to have a mechanism that is limited to sending control messages that is guaranteed to be end-to-end secure, that is guaranteed to provide certain traffic analysis resistance capabilities and is also abuse resistant. Every message that is sent as a message is access controlled at the sending service and the receiving service. So it doesn't prevent spam, absolutely, but it makes it very difficult to make a profit sending spam. Now, I apply this to manage that secure contact exchange, to manage the connection of devices to a personal mesh, but it can also be used for other things. You know, a 50-line application provides us with two-factor authentication. A few more lines allows us to go beyond two-factor. So say I want to add somebody, say I'm adding some payee to my bank account. My bank could send me a message to say, do you really want to use, to add this person to the account, yes or no? I can say yes. And back goes a signed statement that is a second factor authentication because it's bound to the device, but it's also bound to the semantics of the transaction that I actually accepted, which is something you don't get with the numeric code second factor authentication. So I've given you a brief and, whirlwind tour of a bunch of technology, and I hope that it's not been too insensible. But the question that I've now got is, where do we go from here? I'm releasing this stuff. There's already the alpha is out there on GitHub. And I need to start releasing this in the fall because that's when universities start and that's when undergrads and graduate students start looking for projects. And so I want to get this, and I want this to become a standard somewhere. The IETF looks like it's probably the best fit. It may not be. If the IETF doesn't want it, they'll have to take it somewhere else. So the question is this ready for IETF work? Do we need to look at it as an RTF thing first? Should we start a working group? Should we do it as experimental or whatever? But, I'm coming here now because I'm going to start deploying. And the minute that I start to get users, I'm going to be protecting those users. And I'm not going to be wanting to make changes that might introduce backwards compatibility. So, well, unless there's a real value to doing it. So, speak now or hold your peace. So that's it. So, comments?
Stefan Sanderson. I have two questions. First question is IPR. Second question is, how does this fit with existing security protocols who pretty much assumes the one or two key model?
Okay, so on IPR, there is no IPR on any of the stuff that I presented today that I'm aware of. I'm aware of prior art that would invalidate most claims that go back to the 1990s. As I said, this was the basic techniques were developed by Matt Blaze, Torben Pedersen, others. This is threshold cryptography. There's a fairly well-established literature. So I don't believe that there's an IPR blocking issue there. All my code is MIT license, so it's open source in the most open source license. Now, as far as integrating with two-key cryptography, now, you can use the mesh to distribute private key pairs to devices for use with SMIME or with PGP or anything else. The only restriction that you have there is that you would have to be using, if you're going to make use, well, if you just want to distribute RSA keys, you can. If you wanted to make use of the 3-key stuff within PGP, we could extend PGP or SMIME to make use of it. However, you would then have to use elliptic curve Diffie-Hellman or find some other threshold cryptography scheme. The threshold cryptography schemes I use, they're currently using ED 448, the CFRG curve, and I'm using that for signature and encryption. I can use curve X as well instead, but because it's Montgomery, I have to write a different set of code, and I didn't want to do that for expediency reasons I can take offline. So you could use this with OpenPGP. You don't change encryption at all. The only thing that changes is decryption.
Hi, Martin Thompson. Thanks for bringing this here. This is really huge. And that is kind of what I'm trying to get to. If, in my opinion at least, if the IETF takes on work of this nature, it's kind of a major project in the sense that WebRTC was a major project, or SIP was a major project, or something along those lines. So I would suggest, at a minimum, this requires a BOF. And it's good that you're bringing it here and having the discussions. But it also suggests that if you say you're not willing to change your code, there might be a problem, because it's going to take a little while to get this thing moving.
Oh, absolutely. I'm absolutely willing, if somebody will come to me and say, we need to change that or whatever, I'm perfectly willing to do that. However, if somebody came to me today and said, hey, Phil, I've read your drafts, and, if you just changed this or you did this way, I could make radical changes under the hood, and the cost to that would be zero. If, however, we go down the line and it's kind of like people,
I get you.
Yeah, so I'm just saying, please don't wait until people have started to adopt it to read the drafts and then come and say, oh, but you need to do it in ASN1. And it's kind of like, So I'm absolutely happy to make changes. At the moment, this is kind of like the autistic world according to Phil. Yeah, I'm aware of that. And I want to have as much input as possible. But
I do have a question for you. How many other implementers do you have interested in this stuff?
At the moment, I have no implementers. But, I'm coming here to say, one of the requirements for a BOF is that people have to have seen it, which is why I'm presenting here before.
Yeah. Thanks for presenting this. There's a bunch of interesting stuff here. I guess I was sort of thinking same things Martin was asking. I guess this would be a little easier for me to assimilate if it weren't all one monolithic thing. I understand you think of it as components, but it's a little hard for me to reason about it that way. Realistically, we're not going to replace SSH, however much one might not like it. And realistically, we have this enormous installed base of things, right? And my experience, I'm sure yours has been, is that those things don't die easily. So
absolutely, this is not about replacing SSH, but what you could use here is, instead of using, the problem with SSH from my point of view is people use it, but they don't necessarily use it securely. And if you look at some of the guides for how to secure SSH that are out there on the web, it's like, mail yourself the private key so that you can have it on all your devices. And it's kind of like, but what you could use it for is to distribute the SSH keys so that then you can use them. It's got backwards compatibility. It's just that I could have used, instead of the DARE envelope, I could have used PKCS7, I could have used ASN1, I did JSON and that type of stuff.
Sure. Well, I guess, so it would make it easier, at least for me, to understand the situation. I think I understand the threshold stuff reasonably well, but it would make it easier to understand your vision. I think if I understood how it fit in with the things that we've already sort of committed to, like them or not.
Yeah.
Hannes, Phil, on the mailing list, you said that you believe that this has also applicability to the IoT environment, and I was curious on whether you could elaborate on that a little bit.
To the what?
The Internet of Things.
Oh, right. So, yes. So, I could, one of the things the reason that I think that Alice needs some connecting all the devices to something that she controls is that right now I have an enormous number of IoT devices. I'll be talking about this on my Thursday rant on the Pekka Kutcher session. So I've got about, don't tell the wife. $25,000 worth of stuff, right? Okay. So I have an incredible amount of IoT stuff, and I have an enormous amount of accounts with services to manage them. And because of that, I don't have an Internet of Things. None of my devices will talk to each other. And it's got worse, not better. You know, I have all these Nest devices, and they used to talk, and now they're not going to talk. And so what we can do with so if every device has a set of keys for encryption, authentication, and signature that are layered into the device when they join my mesh, then they can talk to coordination, dashboards that I control. And I can get to the point, what I want to do is to drive up to the house and for the doors to open, the lights to go on. And so I need that inter-vendor cooperability and scripting. But right now I can't have it, and we can't have it because the model that everybody has is the device connects up to the service in the cloud to an account run by the IoT device provider, and then my hub in my house connects up to that hub, and then when the internet's out, my house is offline. So in the IoT world, this is a way that you can avoid depending upon that service, and a way that we can get from this current, not an Internet of Things, things that just happen to have Ethernet or Wi-Fi or Bluetooth, but aren't Internet because they won't work with each other. And the thing is that it will be easier and cheaper for you to use my stuff from a toolkit than to invent it yourself.
Thanks.
Hi, Sean Turner. Hey, Phil, I think you've been doing this for maybe longer than I have. So I would say that based on your pitch right now, I would say that this work is not applicable to the IETF because it didn't really sound like you were willing to take changes. If this work gets adopted by the IETF, you might not even be the author of the working group drafts if there was a working group. So whatever the working group consensus would be to change it, we'd change it. So maybe you just misspoke, but I just want to make it clear that you do understand that if this were to happen, then
absolutely. There's two types of changes that happen here, right? Mm-hmm. One of them is somebody says, okay, we want to do this functionality. We want to add that. Yeah, that stuff, perfectly fine. If somebody comes to me and say, oh, that's great, but I want you to do it all in ASN1. And
they may, though. That's the problem, though, right? So if the working group consensus is we want to come up with some new encoding scheme and call it umpty squat, ASN2 or whatever, that's just the will of the working group. Yeah, so I guess if you understand that, that's okay, and I think everyone here does get it, and I'll let that.
Yeah, go. If there's a group of people who are willing to do it and implement and deploy, yeah. Okay. But if it's kind of right now, the point is that right now, if you had some idea that you think would radically improve the functionality, and there was no other reason other than your personal preference, I could do it.
We all know that the standardization process sometimes introduces silly changes that we don't understand or don't like. Like at the end, we had one thing that was a bit string, and it was like, please change it to a Boolean. Sometimes things kind of happen, but you kind of got to do it if that's the consensus.
Oh, yeah,
so, that's just life.
It's basically like the same with security requirements, where we ask people to read the drafts early rather than late. I'm just making that point that, please read the stuff now. Don't wait for 2 years for me to have users and then for me to say, yeah, that would be a really good idea for us to do then, but, legacy deployment's great, but it's also a trap.
Rich Sauls, yeah, it's a trap both ways. So part of me feels like this is sort of like contributing to global warming because the oceans are getting all boiled away. And maybe if there were a simpler, smaller piece that could be split off, and it seems that potentially the UDF stuff, because I know other groups have wrestled with naming keys. OpenPGP, I think, was the last one to die trying to do it. So I'd recommend pulling that work out skipping the fact that it's got 75 possible use cases and it's the solution to world hunger, and just address it's the way to distribute and name keys that is, web compatible.
Yeah, I mean, that would make great sense. And the fingerprint piece could actually be pulled out as a separate unit. The other stuff kind of depends upon the fingerprints as a fundamental infrastructure.
Right, Leif Johansson. So I would take this and go present it at an IW conference, actually, and talk to the self-sovereign people. I think you'd have a lot in common with them. And there is at least conceptually, there seems to be some overlap with what they try to do. I'm not advocating that stuff myself, but I think, well, you may, a little bit maybe, but I would actually go talk to the self-sovereign identity people. I think.
Could you? I'm not catching the word.
Self-sovereign identity. Go Google for self-sovereign identity. If you look at the stuff that they talk about, it looks a lot like this. They're trying to address sort of the same problems. Again, I personally run with that crowd, so I couldn't tell you more about the details, but I do know that they meet at this conference cycle in Silicon Valley called the Internet Identity Workshop. And I think that in that slide, the answer to the question of where, go talk to them first, I think, before deciding this needs to be in IETF. This needs to be in the IETF.
Thanks.
Brett Jordan, I really like this. Thank you for doing this work. I think it's really great. I'd love to work with you on it, whether it's here, whether it's somewhere, whether it's on the moon. I don't care. I think there's some really neat things that could solve a lot of problems. So thank you for doing the work.
Thank you.
Edie, do you want to say anything?
Hi. So personally, thank you for bringing this kind of here, kind of chatting with Ben and listening to the community. I think that folks have poked at interesting parts of exactly what you're suggesting. I think that there were tactical suggestions in terms of responding about kind of scope. What about this? What about that? But I think the overriding thing that resonates for us is this is a big thing. There is no way we can move forward with something of the full scope or even a narrow scope without a BOF. So we would kind of strongly encourage you to pursue that.
Yeah, I mean, I anticipated that. One of the things I'm trying to... The reason I brought it here was that the precondition for having a BOF has to be that there's the right people at the BOF and that they've actually looked at the technology beforehand. So I didn't want to ask for a BOF here because if I did, then nobody would know about the work. So, I'm very happy going forward with a BOF. If people have, my current research concern on it is working out how to scale, because at the moment I've run the numbers, I can run 1 million users, but this is targeting 1 billion. So if people could help me on that right now, I'd be very grateful. But yeah, I mean, a BOF that would be my preferred way ahead.
So a quick question while you're at the mic. Since the next step for this could be a BOF, should we set up a separate mailing list specific to this work to track it?
I think that would make sense if you're up for that, Phil.
Absolutely, yes. I've been going back to the IPR piece, I've been very careful to only discuss this on lists that have a note-well equivalence. And so I want to make sure that we maintain the IPR situation. Thank you.
Great. So mailing list and BOF. Thank you.
Thank you very much.
All right. So the summary from all of them. All right. So the first presentation was...
If anybody wants to talk about it afterwards, meet me.
Yeah, and we'll announce the list name, whatever it is, or Phil will, on the Secdispatch list so you can follow along. Thank you. So from the first, the EST draft from Michael, the decision was that we would dispatch it to LAMPS for the controller Ike. The go forward there was to specify requirements, revise the draft based on feedback, and to continue the discussion for now on Secdispatch to figure out next steps. And for Phil's presentation on mathematical mesh, the go forward is this needs a BOF, it's a large body of work, and the go forward discussions will be on a separate mailing list announced on this one soon. So is there anything else? Blue sheets? Did everyone sign them? And where are they?
You have to return them. You can't take them home.
All right, so just if we could wrap up with the blue sheets, if we could figure out. Oh, okay, so the blue sheets didn't make this side of the room. Are they just sitting somewhere on a chair? Oh, they're up in front.
Okay, I'll bring them around
Got it.
for you.
Okay, thank you.
Other than that, we're done. Thanks.
Thank you, everyone.